Good morning to everyone. I'm going to introduce this presentation that is called Celestite Recovery. I am Noemí Ariza. I am the chemical engineer of Canteras Industriales. Canteras Industriales is the company that operates in Montevive mines in Granada, in Spain, since 1972. The company is focused on the extracting the celestite mineral, is strontium sulfate, and that is the strontium. The strontium sulfate is the main resource of the strontium element. That is this element, as you know, was classified as a critical raw materials by the European Union in 2020. Perhaps due to its economic importance and its interesting application that include permanent magnets, semiconductors, ceramics, and pyrotechnics. This is a small schedule of the geological area of Granada that include Montevive. Montevive isn't just a mine. It's the largest celestite reserve in Spain and also in Europe. And geologically, the Montevive mine is fantastic, is fascinating because it's what generates through a strontium-rich fluid that's replaced a phase called stromatolites by celestite in a Messian evaporitic sequence. And the primary mineralogy consists of celestite with impurities of dolomites, quartz, and clays. Historically, the activity in Montevive was very simple because it consists on separating the high-grade mineral with a grade up to 90% of the strontium sulfate of the rest of the phases, and it's create a big amount of tailings that represent nowadays an environmental liability. The activity of the mine nowadays consists of reducing the need for new blasting and open new pits. For this purpose, Canteras Industriales carry out a multi-scale characterization methodology based on applying fluorescence to obtain a chemical analysis, diffraction with Ribel refinement to obtain the quantitative analysis, CM and TM analysis by microscope. And the result shows that celestite appears with a prismatic crystal that replacing the microcalcite matrix, and the coarse fraction up to 5 millimeters contain higher celestite than the finer fraction. With this conclusion, with these studies, Canteras Industriales conclude that the gravity separation strategy was the best way to obtain the concentrate of celestite, to take a benefit of the density difference between celestite with a high density close to 4 kilograms liters versus the impurities density that is low of calcite and quartz. And Canteras Industriales propose a flow sheet that uses dense media separation methods by hydrocyclone for coarse particles and spiral, Glasgow, and another equipment for fines. It's important to highlight in this point that the desliming stage that consists of removing the fine clays is a critical stage in the dense media separation. In the first time, Canteras Industriales apply a lab scale optimization of hydrocyclone to determine what is the best heavy liquid to apply in the dense medium. concluding that ferrosilicon and a mix of ferrosilicon and magnetite was the best way, and a theoretical optimum of the density of the dense media close to 3 kilograms liters. And with this dense media, we could obtain a theoretical concentration in this point up to 90% of celestite. We follow studying, and the next step was a semi-industrial hydrocyclone test with a hydrocyclone of 250 millimeters of internal diameter, applying a box-Benken factorial design to obtain answer surface by mathematical methods to optimize the main parameters into the hydrocyclone as density, pressure, and inclination. And with this semi-industrial test, we achieve a concentration of the celestite up to 90%. In this slide, in the middle, you can see a scheme of the pilot plant, dense media separation pilot plant, with some of the equipment, a mixed tank, a slurry pan, a worn screw, the magnetic separation, the vibrating screen, and obviously the hydrocyclone. And you can see also the different stage from the lab scale to the industrial scale. For fine fraction that have a poorly behavior into the hydrocyclone, we applied ModSim simulation software that indicate the good behavior of this particle size of a mineral in some equipment such as spiral and shaking tables up to 83%. For this reason, we are now applying a preliminary test in the spiral plant. This justifies a flow strategy based on the particle size. It's important to highlight too that the Classcom and super thickener equipment that is now under validation in mind. Regarding to the ROTATE project, these studies, this research and semi-industrial scale prototypes of dense media and spiral plant had been implemented using the ROTATE project tools. Montevivo and Canteras Industriales had been a pilot site for validating the dense media system, the spiral, Classcom, and super thickened equipment. And the project promotes the industrial symbiosis by recovering value for remaining waste. And regarding to the environmental and sustainability impact, with the super thickener, we are estimated to recover up to 83% of the processed water. With the dense media and other methods to concentrate, we are now valorizing the more than 80% of the tailings that reduce the environmental footprint. And we are reducing new blasting and open pit that save energy and improve the energy efficiency of mine. Only to give details, the value of the celestite had increased in the last few years by 20%, and recovering the tailings obviously improve the operational profitability. And to improve the process, other methods such as flotation will need to be implemented. And in this way, the company will focus on this. As conclusion and future, low-cost, sustainable gravity separation can effectively upgrade a medium-grade celestite. The K2 success is an integrated flow sheet combining the sliming, size classification, and other separation methods. And this model positions Canteras Industriales and also ROTATE as a leader in green mining for critical raw materials in Europe. This is all for my part. And thank you very much.